In this video, we will see about the introduction to chopper fed drive. In that, we have time ratio control and current limit control are two control strategies used in chopper fed drives. Then we will see about the operation of a first quadrant chopper, then how to derive the output voltage and speed torque equation for the first quadrant chopper. Then you have a numerical problem which is solved with step-by-step procedure. This is the block diagram of a chopper fed DC drive system. Here the DC motor is fed from a DC chopper whose input is a fixed DC supply. The output is a variable DC voltage. So by controlling the DC chopper output, you are able to control the input to the DC motor and thereby achieve speed control, or you can control the operation of DC motor by changing the duty cycle of the DC chopper. Normally thyristors are used in earlier days. So since the input supply is DC, thyristors cannot be turned off easily. It needs forced commutation circuit. But nowadays self-commutated devices like BJT, MOSFET and IGBT are preferred in DC choppers. So these devices, when given gate pulse, they will conduct, and if you remove the gate pulse, it will get turned off. So they are called self-commutated devices. Let us see the basic chopper operation. So you take, this is the DC supply available, and this is the load. For instance, let us take a resistive load R, and you connect a switch in between. So when draw the waveform also, so the input supply is a fixed supply Vs. Now when I switch on this device, this supply voltage will be appearing across the load, and when you switch off the device, output will be 0. So it is during on time you will get supply voltage across the load, and off time it is 0. Then again on period you will get the voltage, off period it is 0. So you are getting on period plus off period, and that one cycle of on and off is called the total time period T, or it is equal to 1 by F, that is the frequency. Now you see a red color dotted line, that is the average voltage. So this average voltage will be applied to the DC motor as input. And this is the current. So since it is a resistive load, V0 and I0 will be in phase. So magnitude will be V0 by R. And the output voltage we can write it as Vs into on time period divided by total time period. So here we have seen total time period T equal to T on plus T off. So here you can write T on by T as alpha Vs, where alpha is called the duty cycle whose value varies from 0 to 1. So how output voltage is controlled in chopper? There are two different techniques. One is called time ratio control. Time ratio control, there are two techniques: constant frequency system and variable frequency system. So we have seen V0 is equal to T on by T into Vs. So here you see two variables are there, T on and T. In constant frequency system, as the name says, constant frequency, T is kept constant and you are varying only T on. then it is called constant frequency system. In variable frequency system, you are varying the total time period t while keeping the t on constant. In next technique is called current limit control, where you are controlling the operation by limiting the current within two limits. For example, I have a say I want to control the current between 10 amps and 12 amps. So I will start the chopper at 10 amps, and then when it reaches 12 amps I will stop it. So again when it drops to 10 amps I will start it. So this is called current limit control. The other one is time ratio control, because we are changing the time and we are controlling the chopper. First, let us see about the constant frequency system. So here the chopping frequency is kept constant. You see this waveform. Here you have t on and t off period. Total time period t is there. So in constant frequency system, this t will be always kept constant. See here. Here also t remains constant, but I am changing the on time. So here the output voltage is controlled by changing the on period. This technique is also called pulse width modulation technique. So it is the widely used technique in power electronic systems, because it is the easiest method, pulse width modulation technique. So this constant frequency system is called pulse width modulation technique. So here the pulse width changes as t on changes. So let us see the advantages of this system. So here you will get only less ripple. The main advantage is that your total time period remains constant. So filter requirement is already you can design for a particular frequency. So small filter size is enough, and you get a fast response in pulse width modulation technique. In variable frequency system, as the name suggests, here the time period t or the frequency is varied. So for example, you take this waveform. Here on period, off period is there, and this is the total time period. So in the next waveform you see the t on is kept constant, whereas off period is increased. So the total time period is increased. So in this case we are changing the total time period or the frequency. There are two options. Either you can keep t on constant and vary t off, or you can keep the t off period same and vary the t on period. So two options are there. In both the cases the total time period will change. This method is called frequency modulation technique, because we are changing the frequency. But there are some drawbacks in this method, because as you change the frequency every time, you have to change the filter. So filter design will be difficult in case of variable frequency system. So we will see the limitations. First thing, filter design is difficult, and since we are keep on changing the frequency, there will be interference with the communication lines, and sometimes if you have a large turn off time, this will lead to discontinuous current. Next method is current limit control. So here the switch is turned on and off so that the current always maintained between two limits. So this is the output voltage waveform. So how you are getting this waveform means, first you should monitor the current. So when it reaches a minimum current, you turn on the device, so the current increases, and when this current reaches the maximum value, you turn off the device. Okay. So first we are monitoring the current, then only we are switching on and off the device. So when it reaches a minimum value, turn on the device, and when it reaches the maximum value, turn off the device. So this technique will be used when the load has inductance. This technique is normally preferred in most of the drives. Current limit control. Chopper can be made to operate in one quadrant or all the four quadrants. So these first two quadrant operation you will get when current is positive, and these two quadrants current will be negative. So thyristors are unidirectional devices, so I0 will be always positive. So if you want the second and third quadrant operation also, you have to change the direction of the switches. So you can get all four quadrant operation. So there are different types of chopper for drives. So type A or first quadrant chopper, and type B or second quadrant chopper, type C chopper which operates in first and second quadrant, and type D chopper which operates in first and fourth quadrant, and type E or four quadrant chopper which operates in all the four quadrants. So in this video we will see only about type A or first quadrant chopper. So the type A or first quadrant chopper, it will operate in the first quadrant, that is both VA and IA will be positive. So this is the circuit diagram. So this you may be familiar, it is the basic chopper diagram. So here you have a transistor which is connected to the motor. So this motor, it is a RLE load. Okay. So this is a RLE load, and a freewheeling diode is connected across the motor. So this is the basic chopper circuit diagram, except here you have a RLE load. So when the switch is on, when this chopper is on, what happens? The supply voltage will be appearing across the load. So V0 is positive, I0 is also positive, or you can say VA is positive and IA is also positive. When the switch is off, that is you are removing this switch, then the current actually what happens, it will freewheel through this diode. So when the switch is off, the current freewheels through the diode. So output voltage is 0 and you get I0 as positive. I0 or IA is considered to be positive. Let us draw the waveform. So here current limit control is employed. That is, when the current, armature current reaches a minimum value, the switch is turned on, and when it reaches its maximum limit, the switch is turned off. So this is called the ripple. That is, you can decide the ripple of your armature current accordingly. So if you change this range, your ripple will decrease. So during on period, IARA plus LA into DIA by DT plus EB is the back EMF, that is equal to supply voltage Vs. So during this period, the motor current increases from a minimum value to maximum value. Similarly, during off period, freewheeling diode conducts, that is the current is shorted through the freewheeling diode. So the terminal voltage is equal to 0. Next we will calculate the average voltage. So V average is equal to 1 by total time period T2 integral of limits are 0 to t on, you have the waveform. What is the magnitude? Vs into dt. So simplify it. So t, you apply the limits, so you will get t on by t. So what is t on by t? That is the duty cycle alpha. So some people used to write alpha, some used to write capital D, and in some you have del as duty cycle. So you can follow anything. So I have taken alpha is equal to T on by T. So this is the average voltage. This red color line is the average voltage. Next we will derive the speed torque equation. Again I am telling it is similar to the phase control rectifier fed drive. VA is equal to EB plus IARA for motor. You equate this equation to your average value. So alpha into Vs is equal to EB plus IARA. So EB is Km omega m. So from this you find what is omega m. And here you want torque equation. Here you have current equation. So you write this relation, torque is equal to Km into Ia. From this, instead of Ia you substitute torque by Km. So you will get the speed torque relation. And you can draw the speed torque characteristics. This arrow indicates that for increasing alpha you get the characteristics like this. So the advantages of chopper fed drives are high efficiency, flexibility in control, small size, and quick response you can get with chopper fed drives. And the advantage is that you can also achieve regenerative braking, or you can give the energy back to the supply in chopper fed drives. Let us see the applications. So it is used in variety of applications, especially in battery operated vehicles. For 4-quadrant operation purpose you can use this type of chopper fed drives. Let us solve one problem. See, in chopper circuit all the problems appear to be a big one, but it is very easy because in chopper you don't have any formulas to remember. Only 2 or 3 formulas are there which you can remember easily. So don't skip any problem in chopper. So let us see the problem. The speed of a separately excited DC motor is controlled by a pulse width modulation chopper. The DC supply voltage is 120 volt, armature resistance is given, and motor constant is 0.05 volt per RPM. Now you may get a confusion, what is this constant? So you see the unit, it is given voltage per RPM. So what is the back EMF formula? Km into omega m. So Km is back EMF divided by omega. It means that voltage per speed. So that is given. Then the motor drives a constant load torque and the average armature current is given. You have to find the duty cycle as well as speed. So first the given data we will write supply voltage, armature resistance, and the motor constant. So you be clear in this. Back EMF is equal to Km into omega m, where this omega m is the speed. So it is speed is given in RPM and EB is given in voltage. So what is given is Km. Then armature current is given. So you have to find what is the duty cycle as well as what is the speed. Now for a PWM chopper we know VA is equal to alpha Vs. we can also write it as EB plus IARA, where EB is equal to Km omega m. So you got this equation. Now what we have to find is what is the alpha at minimum speed and maximum speed. But we don't know the maximum speed and minimum speed. So for a constant load, we can take the minimum speed as 0. So at 0 speed, what is the alpha? That is what we are going to find out first. So alpha into alpha we don't know. Vs we know it is 120. Speed is 0 because we are finding the alpha for minimum speed. So omega m I am taking as 0. So this term becomes 0 plus IARA. So from this you will get the alpha value. So we got alpha for minimum speed. Then what will be the maximum speed? We don't know, but we know that when we apply the full voltage, you will get maximum speed. So at alpha equal to 1, you will get the maximum speed. So the range of duty cycle is 0.083 to 1. Next we have to find the range of speed. We know the range of duty cycle, and at alpha equal to 0.083 our speed is 0. At alpha equal to 1 you will get the maximum speed, which we have to find out now. So same equation. From that you find what is omega m, because we have to find the speed. So you substitute everything, you will get the speed in RPM. So this is the maximum speed, or the speed corresponding to duty cycle 1. So this is the answer. So the points to remember here are: a chopper can be controlled by two methods: time ratio control, where you have two different techniques, constant frequency system and variable frequency system. In constant frequency system is also called as pulse width modulation technique, where the frequency is kept constant. So this method is widely used. In variable frequency system, the frequency is varied, so it is called a frequency modulation technique, but this has some drawbacks, like as the frequency changes, filter design is difficult and it can cause interference with the communication lines. Another method is current limit control, where you will be controlling the current within two limits. And the formulas to remember here are: V average is equal to alpha Vs, where alpha is the duty cycle. If you like the video, do subscribe to Read Electric Vehicle channel, and these are the references. Thank you.